Okay, this is the bonus lesson 3.6. This on 3x3 systems. So we've been solving 2x2 systems, which means we've had two variables with two equations. So these are a little bit more difficult. We're going to three equations with three variables. And we're only going to do these by elimination. We're certainly not going to try this by graphing because that's in 3 dimensions. And then you could do them by substitution, but elimination is certainly easier. So let's look at the big idea that we're going to use here to solve a 3x3. Okay, so we'll look at this statement right here. I'm going to make the 3x3 into a 2x2. And the way I'm going to do that is by eliminating the same variable twice. So if I get it to a 2x2 system, then we know how to do 2x2s. So let's look at a couple of examples here. I'm going to use some that are in your text. So if you want to look at them and follow along in your text, you can. They're on page 152. Okay, so let's look at this one and sort of examine it here. Again, there's three equations with three variables. So instead of x and y, we've got x, y, and z. So again, the key is I want to make this 3x3 into a 2x2. And so I'm going to eliminate the same variable twice. Okay, so what I'm going to do is pick two of those equations and eliminate a variable, and then pick two different equations and eliminate that same variable. So when I examine this, it sort of looks easier to see here that the z's are probably going to be easier to eliminate than the other two variables x or y. So I'm going to eliminate the z's here. And so what I'm going to have to do is do two eliminations. So the first elimination I'm going to do here is I'm going to pick the second and the third equation, because I notice if I combine those, then those z's will eliminate. So I'm going to copy the second and third of x plus 4y plus 2z equals 16. And then I'll copy this other one, 15x plus 6y minus 2z equals 12. Okay, so the z's eliminate, and so now I'll get 16x plus 10y equals 28. Okay, so notice I got down to an equation that only has two variables instead of three. So again, I want to make a 3x3 into a 2x2. So now I've got one equation with two variables. Now what I need to do again is eliminate the z's again to get another equation with x and y. So obviously here I cannot choose the same two. I can't choose these two equations again. I'm going to have to choose two different ones. So when I examine these, I think what I'm going to do here is choose these two equations. So notice the first, I chose those two to eliminate z. Now I'm going to choose these two to eliminate z. So those don't automatically eliminate. So I'm going to have to do some multiplying for that to happen. So you can probably figure out that I'm going to have to multiply this equation by 2. All right, so let me show that here. I'm going to take this equation, multiply that one by 2. All right, so I'm going to write it over here to the side. I'm going to have 4x now plus 2y minus 2z equals 10. And now I'm going to copy that second one, x plus 4y plus 2z equals 16. So when we combine these, again, the z's eliminate. And usually what's important to remember is I have to eliminate the same variable twice. I eliminated the z now twice. This is going to give me 5x plus 6y equals 26. So now I've successfully here taken the 3x3 and made it into a 2x2. All right, so there's my two equations for my 2x2 system. So let me write it down over here. So it's gone from a 3x3 to now a 2 by 2. So we'll recopy these. 16x plus 10y equals 28. And then this one's 5x plus 6y equals 26. Okay, so now I'm going to work on this 2 by 2 system. So my focus now is going to be solving this one. Well, 2 by 2s, we've been doing those for a while, so those aren't very difficult to do. And this one has a lot of big numbers, so it's a little bit harder. Now I'm going to choose to eliminate the y's here. So if I looked at 6 and 10 here, I could figure out the least common multiple would be 30. So I'm going to get one of those to be positive 30 and then the next one to be negative 30. So to do that, I'm going to have to multiply this one by 3. And so now this is going to give me 48x plus 30y equals, and then let's see, 28 times 3 is 84. Okay, so now that's the 30. Now to get this one to negative 30, I'm going to have to multiply that equation by negative 5. So when I multiply that one by negative 5, I'm going to get negative 25x minus 30x, and then 26 times negative 5 is negative 130. So when we combine these, 48 minus 25, it's going to give me 23, so it'll be 23x. The y's here eliminate, and then 84 minus 130 is negative 46, and negative 46 divided by 23 would be negative 2. So I finally got one of the solutions here is negative 2. Now I haven't solved the 2 by 2 yet though. That's only one of the variables. So I'm going to take the negative 2 and go back to the 2 by 2, not the 3 by 3, but this 2 by 2 right there and substitute the x in. I'm going to choose this bottom equation because it looks a little bit smaller there. So when I make those substitutions, when I substitute negative 2, that's going to give me negative 10 plus 6y equals 26. Now I can solve that for y. So I'm going to get 6y equals 36, so y is 6. So now I've solved the 2 by 2. Now it's time I got to get one more variable. So to get the very last variable, you go all the way back to the 3 by 3. So on this 3 by 3 now, I'm going to substitute negative 2 and 6 in to any of those three equations. It would not matter which one. I think I'm going to just go probably with the top one. The numbers are a little bit smaller there. So I'm going to put negative 2 in for that x, and then 6 in for that y, and then I'll be able to find out what z is. So 2 times negative 2, that's going to give me negative 4, and then plus 6, now minus z equals 5. So negative 4 and 6 would give me a 2. So 2 minus z equals 5. So we'll subtract 2 from both sides here now. So we'll get negative z equals 3. So z would be negative 3. So finally now I've got my solution. There was the x, there was the y from the 2 by 2, and then the z from the 3 by 3. So I'm going to write it in what's called an ordered triple. You do it in alphabetical order here. So it'd be negative 2, comma 6, comma negative 3. So you can check in your textbook here and maybe see how they did it. They may have done it a little bit different. I didn't really pay attention to the way that they solved it. But there's several different ways you can do these because this just depends on which variable you decide to eliminate to get down to your 2 by 2. So you notice these are a lot of work. They're not really that difficult once you get the big concept. Now, I'm going to do one more for you. This one's on the bottom of page 150. This is the check for understanding example. Okay, again, that's on page 150. This one's actually a little bit easier. So if you'd like, you may want to pause and actually try this yourself first and then kind of come back and watch me do this. Now, I'm going to decide first on a variable to eliminate. So I'm seeing maybe here to eliminate x's wouldn't be that bad because this x doesn't have a coefficient on it, or you may see that the y's are easier to eliminate, so it's just sort of up to you. I think here I'm going to go with y's. All right, so I'm going to eliminate the y's, and I'm going to have to do it twice to get a 2 by 2. So what I'm going to do is put these two, the second and the third equation together to eliminate the y's, but notice there that I'm going to have to multiply that bottom one by -2 for that to happen. So I'm going to copy the middle one over here. And now I'm going to do the bottom one, but again, I'm going to have to multiply this one by -2. So that's going to give me -4x minus 2y minus 10z equals -16. Okay, so the y's are going to go the way, and I'm going to have an equation that just has 2 variables instead of 3. So this will give me -x, and then 3z minus 10z would be -7z equals, and 7 minus 16 would be -9. Okay, now I need another equation with x and z in it so I can get a 2 by 2. Again, I'm trying to get a 3 by 3 to a 2 by 2. So I'm going to go back. I'm not going to do this again. So I think what I'll do here is choose these two equations this time. Okay, so I have to do two different equations. I can't do the same two over again because that would just give me the same equation back. So notice if I use these two, and again, I have to eliminate the y's again. I can't eliminate the x's now because I decided in the first one to eliminate y's. So if I eliminate the y's the first time, I've got to eliminate the y's the second time also. So notice if I eliminate the y's here, I can probably multiply this one by -2, and then that would eliminate the y's on that. Okay, so let's show that I'm going to multiply this one by -2. Okay, and I'll recopy the first one. So we recopy the first one. We've got x plus 4y minus 5z equals -7. And then the second one by -2. So this will give me -6x minus 4y minus 6z equals -14. So the y's are going to eliminate. This is going to give me -5x, and then minus 11z equals -21. And so now I've got a 2 by 2 system. I went from a 3 by 3 to a 2 by 2. So I've got this equation and this equation. I'm going to put those together to make a 2 by 2. So let me make it into a 2 by 2 here now. Let me recopy them. -x minus 7z equals -9, and then -5x minus 11z equals -21. So I'm down to a 2 by 2. 2 by 2 is a little bit easier to solve. And so my 2 by 2, I think I'm going to choose to eliminate the x here. So this one's -5x. I need the top one to be +5x. So I'm going to multiply the top here by -5. So that's going to give me +5x plus 35z equals 45. And let me recopy the second one here. So the x's will eliminate. 35z minus 11z here would give me 24z. And then 45 minus 21 would be 24. So now we're going to get z to be 1. Now, I haven't completely solved the 2 by 2 yet, so I'm going to put z equals 1. I'm going to put 1 back into the 2 by 2. So I think I'm going to choose that equation to put z back into. So I'm going to put 1 in place of that z and then solve that one for the x. So I'm going to have negative x minus 7, because we got negative 7 times 1 there would be negative 7, equals negative 9. And so if I solve for x here, I'm going to add 7 on both sides. That's going to give me negative 2. And so x is 2. So I've got x is 2. Z is 1. Now I'm still missing y. So to get the final variable, we're going to go back into the 3 by 3. So I'm going to substitute the 1 in for z and the 2 in for x into any of these equations in here to the 3 by 3. I think I'm going to go with a top equation. It looks probably the easiest one to go back into. So I'm going to use, again, the top one. And so I'll substitute x and z and solve for y in that one. So substitute x there, that would be 2. And then I got plus 4y, I don't know the y yet, minus 5z, so minus 5, and then I will put z in right there. 5 times 1 would be 5, so it would be minus 5 equals negative 7. And now I could solve this one for y. 2 minus 5 here would be negative 3. And then I would add 3 here. And so that gives me negative 4. And so y would be negative 1. So I have my solution here. I'll put it in alphabetical order in what's called an ordered triple. So it would be 2, negative 1, 1 is my solution. Okay, so some advice here. You may want to get some long paper because these take certainly a lot of paper to do, a lot of effort. All in all, they're not that hard. It's just more effort than it is difficulty. Now, so those are the 2 examples I'm going to do for you. Now, I'm going to recommend these problems for you. So on page 153, numbers 14, 15, and 18, and these are the answers to those problems. So you'll know if you get them wrong or right. Now, I'm not going to give you any bonus points for doing this, but instead, on your next test, you will have a 3 by 3 system as a bonus question. So if you can get that bonus right, it probably will be worth about 10 points here on your next test, which will actually go on the next 6 weeks. Now, for a bonus now, so understand these are not bonus questions. These are just practice problems that you can do before the next test that will help you get the bonus question right on the next test. Now, here's our real bonus here. So notice this is truly challenging. And notice that this is going to be due, this is November the 3rd. You have to turn it in by 8 o'clock. Certainly you could turn it in earlier if you want to. I believe that's on a Thursday. So notice what this one is. This is not a 3 by 3. It is a 4 by 4. So it's even more difficult. I've actually in a college class had to do a 5 by 5, which was extremely difficult. Now, so I'll give you a big strategy here. We've got a 4 by 4. So the big idea here is you want to take a 4 by 4 down to a 3 by 3, and then take the 3 by 3 down to a 2 by 2. And so there's your idea behind that. Now, so I know probably our next question is this. Okay, what's it worth? All right, well, that depends. Okay, the more people that turn it in, the less it's worth. So why? Well, that's so you won't let someone copy yours. If someone copies yours, that means yours is worth less on the bonus. So don't let somebody copy your problem. You do it on your own here, and then you'll be rewarded for it.